students, welcome to this video session. My name is Samuel Chukwuemeka. In this video session, we shall discuss the second part of logarithms. Here we shall talk about the laws of logarithms, and we shall solve some questions involving the applications of these laws. Please, before you view this video, it is recommended that you view the first video that I did on logarithms, and that video is an introduction to logarithms. It is highly recommended that you view that video prior to this one. So let's quickly talk about the laws of logarithms. This is similar to the laws of exponents. When you what do you have in exponents? So the first law, we can say that the logarithm of a product, log of xy, x times y, will give you log x plus log y. Okay? Log of the product of x and y will give you the log x, the sum of log x and log y. Okay, so when we have something like log of 6, we can say it's log of 6, we can have it as log of 2 times 3. Okay, remember, if you don't see any base, that means it's base 10. Remember that. If you don't see any base, it means base 10. So this is kind of log 2 times 3, and that will give you log 2 plus log 3. Okay, base 10. Now this can also happen in any base at all. Any base at all. So if we say maybe log to base 5 of 6, log 6 to base 5, it is still the same thing as saying log 2 times 3 to base 5, right? And it's still the same thing as saying log 2 to base 5 plus log 3 to base 5. Okay? And this law is vice versa. Vice versa, meaning that you can also, it works the other way around. For instance, you can have it that log 2 times 5, 2 times 3 base 5, we see that it's log 2 to base 5 plus log 3 to base 5. You can also have it the other way around. If you have log 2 to base 5 plus log 3 to base 5, you can also say that it is log to base 5 2 times 3. And that will give you log 6 to base 5. So you can also have it vice versa, the other way around. Okay? And if we do, this works also for algebra. It doesn't just work for the arithmetic, the numbers we did. Okay? Just like you have here, let's say if you have log b base a plus log c base a. Alright? You can work the other way around. Because this is base a, this is base a, you bring down base a, and this will be b times c. Okay? And this will now give you log bc base a. So that is the first law of logarithm. Log of the product will be the sum of the log of the individual elements. Okay? Alright, second law. The second law of logarithm. Let's look at log of a quotient. If we have log x over y, x divided by y, log of a quotient, now this will now give you the difference, log x minus log y, to give you the difference of the log of the individual elements. Okay? So, let's say you have log 10 over 2. Okay? Log 10 divided by 2. Okay, this means log of 10 base 10, because if there is no base, that means it is in base 10. So this is log 10 base 10 minus log 2 base 10. And you can also do it vice versa. It could also be the other way around. If you have log 10 base 8 minus log 2 base 8, then you bring out the base. This is base 8. This will be log base 8, 10 divided by 2. And that will give you log 5 base 8. So it could be the other way around as well. Yeah. And it could also apply to algebra, just like you have it here, algebra. It can apply to algebra, it can apply to arithmetic, numbers. Okay? It can apply to variables, it can apply to numbers. Alright, let's look at the third law. The third law of logarithm. If we have if you can recall in exponents, the laws of exponents, when you have a raised to power 1, that gives you a, right? If you have 5 to the power 1, that gives you 5. If you have a Mr. C raised to the first power, it gives you what? Mr. C. Anything you raise to the first power will give you that thing. So in this case, we can say that log of a base a will give you 1. Because if you recall, in the first video, the relationship between exponents and logarithms. Okay, when you have a raised to power 1, it gives you a. So log a to base a is 1. Log 7 to base 7 will give you 1. Log 10, of course, log 10, if you write it like this, or you can write it like this, log 10 to base 10, or you can write it like this, log 10 to base 10, is 1. You know that you can write your base in words. You can write it in words, not just in numbers. It must not be numeric. You can also write it in words. Okay? Log Mr. C to the base of Mr. C will give you 1. Okay? So that's the third law. So we want to learn this, that log of anything to the base of that thing will give us 1. The fourth law, let's look at the fourth law. When we have, just like in exponents, when we have a 0 exponent, okay, when we raise anything to the 0 power, it gives us 1. Okay? Yeah, when we do a raised to power 0, it gives you 1. If we do 7 to the 0 power, it gives you 1. Right? If we do Mr. C to the 0 power, it gives you 1. So in this case, log of 1 to any base at all will give you 0. Okay? So we say that log of 1 to any base will give you 0. Because anything raised to power 0 will give you 1. Okay, when we say log of 1 to base 7, it's going to be what? 0. If we say log of 1 to base a, it's going to be 0. If we say log of 1 to base Mr. C, it's going to be 0. Okay? Now let's look at the fifth law. The fifth law now, when we, just like in the fifth law, we talk about if we have a number that has an exponent and we want to take the log of a number with an exponent. Okay? We have a base, but we have a number with an exponent. Or you can say just log of an exponent. What will it be? If you have log of a raised to power m, now this means base 10. This means m log a. If you have log to base 5, 2 raised to power 3, right? This will give you 3 log 2 base 5. You see the exponent now comes back. The exponent now comes in front of the log. And this could be vice versa. It could be the other way around. If you have 3 log 2 base 5, you can now say that this is log base 5 2 cubed. 2 cubed. Okay? If you have a log of 100, now we know that this is base 10, right? So this means log of 100 base 10, right? And this is equivalent to log 10 raised to power 2 base 10. You see? So this will now give you 2 log 10 base 10. And log 10 base 10, remember what we did in the third log. Log a base a is 1. Log 5 base 5 is 1. Log 7 base 7 is 1. So this is 2 times 1, which is 2. So, but this was not the way we did it in the first video, but this is kind of another way you can do it. All those things we did in the first video, you can now do it this second way by knowing this, knowing the laws of logarithm or the properties of logarithms. Okay, all those things we did in the first video. Let's do some more problems. Let's do some more applications of this law. If we have something like log 0.1, right? So we see that log 0.1 means log to base 10, 0.1. Okay? Then what we have to do now is we try to express 0.1 as an exponent. Okay? Now this will be log base 10, 10 to the negative 1. Because 0.1 means 1 over 10. Let's take it as 1 over 10. That's what it means. So this means log to base 10, 10 to negative 1. But this was not the way. We did this question in the first video. We did it in the first video, but this was not the way that we used. Okay, but with this second video, you can now do it this way. Okay, so this is now negative 1 log 10 base 10, and that is equal to negative 1 times 1, which is negative 1. Okay? But remember, but if you recall, in the first video, we did it this way. When we have log to base 10, log 1 over 10 base 10, we say let it be x, and then we did 10 raised to power x to be 1 over 10, then 10 raised to power x to be 10 to the negative 1, and x will be negative 1. So either way, either method is fine. But you know, I had to teach you this method first, because this is the definition of logarithms. Then after the definition, if you understand the process of the definition, then you now learn the laws of logarithm. Yeah. So you can do it either way. Yeah. Practice, you know, practice makes perfect. Practice makes perfect. By the time you do a lot of it, you know, you will master it. Let's do one more problem here before we go to the next law of logarithm. If we want to find something like maybe log 125 base 5, right? Log 125 base 5, you kind of want to simplify it. So this means log 5 raised to power 3 base 5. Okay? And that means 3 log 5 base 5. And that means 3 times 1. And that means 3. Yeah. But the way we did it with the definition, we just say let log 125 base 5 be p, And then you now, from the definition of logarithms, you now do 5 to the power p will be 125. Then you now do 5 to the power p to be 5 cubed. And then p will now be 3. Whichever way is fine. But for this video, I want us to work with this. Okay? Alright, now let's take the next law of logarithms. The next law of logarithms, that's the sixth one, will have to deal with the change of base of logarithm. We will do another video that will illustrate the examples of change of base. But yeah, the questions here are mainly with the first 3 laws thereabout. Okay, now change of base of logarithms. If we say a change, maybe you have a log x base y. You want to change it to base z. Okay, it is in base y, but you want to change it to base z. So how are you going to do that? Okay, sometimes there are some problems in logarithms that will require you to change the base. So how would you do that? Okay, so this will now be that log x base y. If you want to change it to base z, this will now be log x base z all over log y base z. Log x base z divided by log y base z. So this is the formula here. Okay? And there are several ways to solve this kind of question. This question is, where you apply something like this is where when you have fractional bases. If you have fractional bases, like if you have log 4 base half, base 1/2, yeah, you can still do it by definition of logarithm. If we have log 4 base 1/2, we can do it 2 ways. Okay, let's solve it. If you have log 4 base 1/2, you can do it 2 ways. Some people will choose to do it with the definition of logarithm. They will just say, let this be k. And then this will be 1/2 raised to power k will be 4. Right? And this means 2 raised to power -1 times k will be 2 raised to power 2. And this will be 2 raised to power -k will be 2 raised to power 2. So you have the same base. You can equate their exponents. This will now be -k equal to 2, and then k will be -2. If you divide both sides by -1. Okay, that is one way to do it. Another way to do it is to do the change of base of logarithm. That's another way to do it. So if we have to do it with the change of base, you have a log 4 base half. You probably want to change it to base 2 because 2 will be the easiest to work with as they are kind of multiples of 2. So this will now be log 4 base half will now be log 4 base 2 all over log 1/2 base 2. Okay, you've changed it to base 2 now. And that will now give you log 2 raised to power 2 base 2 all over log 2 raised to power -1 base 2. You see that? So that will give you what? 2 log 2 base 2 all over -1 log 2 base 2. So you kind of see that this is now 2 times 1 over -1 times 1, which is 2 over -1, which will give you -2. -2, the same thing. Yeah. So this change of basis is is really helpful when you're dealing with a fractional basis of logarithms. I mean logarithms of fractional basis. That's when the change of basis really helpful. Yeah. And if you kind of want to see whether, just a simple check on whether this change of base really works. You can kind of do a simple check on it. You can just use like some numbers. You might just say log 64 base 4. Okay, log 64 base 4, we know that it is log 4 cubed base 4. And that will give us 3 log 4 base 4. That will be 3 times 1, which is 3. Okay? But let's say you want to know whether change of base works. You want to change this log 64 base 4. You want to change it from base 4 to base 2. Okay, let's say you want to change to base 2. Change to base 2. So this will be log 64 base 2 all over log 4 base 2. All you're doing is when you're changing to a base, you just want to change both the logarithm of the number and also the base to the next base you want to do, and you express it as a quotient. Okay, so this is now log 2 to the power 6 base 2 all over log 2 to the power 2 base 2. So this gives you log 6 log 2 base 2 all over 2 log 2 base 2. And this gives you 6 divided by 2, which is 3. The same thing. So that is it with laws of logarithms. In the next video we shall solve some questions. Okay? In the next video we shall solve some questions. Thank you so much, students, for listening to this video presentation.